Alright guys, welcome to this page of the notes. Again, what we're doing is we're working on rotations. There are four common angles of rotation: 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Let's go ahead and do another one of these together. Hopefully what you've done is you've tried on your own. You're coming back to check your answer with what I've got. I've been given a triangle KLM. I want to rotate it 180 degrees. Let's go ahead, label our vertices A. Oh, sorry, I have K, L, and M. That would be confusing if I did A, B, and C. We'll do K, L, M. And here we go. Hopefully, again, if you've forgotten, go back to the previous page of the notes. The transformation for 180 degrees is going to be the negative of X and Y. So they stay in the same spot, but X becomes negative, the Y becomes negative, and here we go. K is at 1, negative 4. So 1 minus 4, which means the transformation is going to take it to K prime, which is going to be at minus 1, positive 4. Awesome. L. 1, 2, 3, 4, negative 1, 4 minus 1, which means the transformation is going to map L prime to negative 4, positive 1, and M. M is at 2, negative 1, which means my transformation is going to map it to M prime at minus 2, positive 1. We'll plot those points. Negative 1, 2, 3, 4. That's K prime. There's L prime. That's M prime. Again, the idea is this: K prime, L prime, M prime. If this is the origin, is my point of rotation, hopefully you can see I've rotated this object 180 degrees around point P, which makes perfect sense, right? Because if I draw that line from M to M prime, I go right through that point of rotation. They're the same distance on either side, and look, it's a straight line, right? It's a straight line from M prime to M, or M to M prime. A straight line is 180 degrees. So, makes perfect sense. Everything checks out. We look good. Let's do another one. All right, we want to go 90 degrees. We've got P, Q, and R. P, Q, and R. Again, hopefully, if you need to, go back and check, but you remember to do a 90-degree rotation. The transformation is going to be minus y, comma, x, and here we go. Point P is at 4 minus 3, which means that it is going to be mapped to P prime, which is going to be at 3, 4. Q is at 1, 2, 3, 4, 1, which means it's going to be mapped to Q prime, which will be at, switch them, make the y negative, so minus 1, 4. And finally R, 2, 1, which is going to be mapped to R prime, switch them, so negative 1, 2. Let's plot those guys and see what we get. We're going to be at 3, 4. 1, 2, 3, 4. Right there is P prime. Q, minus 1. That's Q prime. R prime, minus 1, 2. R prime. Again, this idea right here, if the center or the origin is the angle, or is the point that I am rotating around, here's what I should see. If I draw a line from R to that point, and then from the point to R prime, let's see what we get. I'll do it in black. There's that guy, there's that guy. Look at that. Those lines should be the same distance, and they need to form a right angle. It's a 90-degree rotation. I just take a quick look at it, and that looks good to me. They're both the exact same distance, and it does form a right angle. I feel really good about the way that problem worked out. All right, let's go ahead and do another one for you. Here's what we've got in this one. I am asking you, I've given you the pre-image, right? A, B, C, D, and its image. A prime, B prime, C prime, and D prime. I want to know, oh, sorry, let me make that bigger so you can see it. I apologize. There you go. Hopefully that's a little easier to read. I want to know, there's my point P, that is the angle, that is the point through which I'm going to rotate. I want to know, can you figure out what is the angle of rotation? Now, again, if you have a protractor, please feel free to use the protractor to measure the angle of rotation, but there's those 4 common ones, and those are really the ones that if you're taking this class with me, that I would test you on. I could go from any point I want to. I could go from A to the point to A prime. I could go from B to the point to B prime, D to D prime, C to C prime, whatever, it doesn't matter. I'm going to pick an easy one. Let's go B. And then from P to B prime, and what does that look like to you? Does that look like an angle of rotation of 90, 180, 270, or 360 degrees? Well, it's definitely not 360 because that would bring the image all the way back around to where it's at, and they're not. They're 2 different images. They don't lie over top of each other. So 360 is out. 360 is out. Can't be that. 180 degrees would mean that I would be in a straight line. 180 degrees would be a straight line. I definitely don't have a straight line. It definitely makes an angle. So it's got to be either 90 or 270. 90 degrees or 270 degrees. Right? Well, take a quick look at it. If you can draw that little right angle symbol in there, which I can, cuckoo, cuckoo, we've got ourselves our winner. This is an angle rotation of 90 degrees around point P. Guys, thank you so much for joining me for this set of videos and these notes. Hopefully at this point, rotations make a lot more sense to you guys about mapping rotations, the 4 common ones, 90, 180, 270, 360. All right, we've given you the transformations for making those rotations around a point P, which will always be at the origin. And then again, if I give it to you, can you figure out which? It'll be one of those 4, especially if you're taking this class with me. But feel free to use a compass if you need to. Again, thanks so much for joining me for this set of videos. I'll see you guys next time.